Hello guys, welcome to the Have Lab today. My name is Babatunde and today we're going to be talking about ordering integers. Okay, based on the title of this objective, we're going to basically means we're going to be working on observation of integers. Okay, integers basically means numbers. Okay, any number given to you, as long as the number doesn't have a decimal point attached. So what the decimal point means is these kind of numbers. This is a decimal point. As long as it doesn't have this kind of number attached, or it's not like a fraction type of number like this. Okay, these are not integers. Okay, these are not integers. Okay, integers are normal numbers, like numbers we count, like 1, 2, 3. It can also be negative numbers also. Okay, it can be -5, -7, all those numbers. Okay, these are integers. Okay, and in this question, we're going to be observing these integers. Okay, and based on observation, we would determine if the number is going to be greater than, less than, or equals to. Okay, so this sign means greater than. This sign itself means greater than. This sign means less than, and this, I'm sure we're all familiar with this. This means equals to. Okay, so based on our observation on these integer numbers, okay, we'll either determine whether the two numbers will be greater than, or if one of them will be less than, or if one of them will be greater than, or if the other will be, if they will be equals to each other. Okay, so let's get to it. Let's look at the question. Okay, this one, the question tells us to use less than sign, which is this, greater than sign, which is this, or the equals to sign, which is this, to compare the following numbers. Okay, so this is the first question, this is the second, this is the third, the separate question. Okay, so we're asked to use these symbols to compare the numbers. Okay, and we have to observe the numbers in this case. Okay, one general rule I want to point out is any number that doesn't have a negative in front of it. Okay, let's say we're working with 5 and -6. As long as this number doesn't have a negative in front of it, it's automatically bigger than this number. Okay, so whenever you're dealing with problems like this, you always know that a positive, okay, because this is a positive, as long as it has a positive, or it doesn't have a symbol, a sign of negative in front of it, it is automatically bigger than any negative number. So all positive numbers are automatically bigger than all negative numbers. So if you see a positive number and a negative number and you're trying to compare, you know that the positive number is going to be greater than the negative number. Okay, based on the number line. Okay, this is the number line. This is how it works from 0 to negative infinity to positive infinity, right? So in this case, positive infinity is in front of negative infinity, right? So numbers work from negative infinity because we don't know. The reason why I use infinity is because we don't know where the numbers stop. Okay, numbers don't stop. Okay, so we work from negative infinity all the way to 0 and then to positive infinity. And we are aware that positive always comes before negative, right? So based on that, we know all positive numbers are greater than all negative numbers. Okay, so based on that, we will be able to solve this first question. Okay, this first question, we're given two separate numbers. Okay, this is a positive number. Okay, it doesn't matter if they don't put in the sign, as long as there's no sign, it's automatically a positive number. Okay, so this is a positive 2 and this is a negative 2. Okay, and based on what I just said, all positive numbers are bigger than all negative number. So any one is bigger than negative 1 billion. Okay, so whenever I see any positive number and a negative number, just know that the positive is greater than the negative. Okay, so this is the positive and this is the negative 2. Okay, so that means based on what I just said, positive 2 should be greater than negative 2, right? And this is the greater than sign. Okay, based on that, we plug in this as the greater than. Okay, so the next one, we're dealing with two negative numbers. Okay, I want to find out which one is greater than which one, or which one's less than. Okay, and based on the number line, okay, we're going to be working um, from negative numbers as well. Okay, so what this means is basically saying negative infinity. Okay, this is possibly the biggest negative number you can think of. All right, and numbers always start from negative infinity. It works all the way from negative infinity all the way to zero. Okay, so for a number to be bigger than another number in a negative, when you're working with negative numbers, right? For a number to be greater than the other number, for a number to be greater than its latter, that number has to be closer to zero than the latter. Okay, so let's say we're dealing with -2 and -4. Okay, -2 will be bigger than -4 because as we count from here, okay, to go all the way to zero. So let's say we'll start from -6. Okay, so if you count from -6, it goes down to -5. Okay, and then a -4, and then -3, -2, -1 before it gets to zero. Okay, so kind of think of negative numbers as a ticking bomb. Okay, you know, numbers count from upward downwards instead of upward from downwards upward from upward downwards. Sorry, it starts from like you know, the 10, 9, 8, 7. You know, yeah, that's how it goes in the negative aspect. Okay, but when you're dealing with positive, the number goes upward. Okay, it starts from 1, 2, 3, 4 to infinity. Okay, but when we're dealing with negative numbers, right, the one that is the biggest are always the ones closer to zero. Okay, so in this case, the biggest negative integer you can get is -1 because it's the closest to zero. Okay, because after -1 is going to be zero, right? But if we're dealing with two negative numbers like this, -2 and -4, which one of them do you think is closer to zero based on this, based on what I wrote here? -2 is closer to zero, right? Okay, because -2 is like one step before zero. Okay, but -4 is like is at least three steps of four zero, right? So based on that, we know that when we're dealing with two negative numbers, the number that's closest to zero is always the bigger one. Okay, so let's look at these. Okay, this is -5 and -9, right? And so based on that, which one of them do you think is closer to zero? Okay, so even if I don't write -9 here, we know -5 should be closer to zero, right? Because -9 comes from way back behind, right? It goes -10, -9, -8, -7 before it gets to -6. So -9 is further from zero than -5, right? -5 is the closest to zero. Okay, and since -5 is the closest to zero, it's automatically bigger than. Okay, so the number that is closest to zero is the bigger number in the negative aspect. Okay, so these are two negative numbers. So -5 should be greater than -9, right? Because -5 is closer to zero than -9. Okay, and 8 and 6. Okay, we're dealing with normal positive integers. Okay, 8 and 6. Okay, so when you're counting your numbers, let's say we're counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, unlike negative numbers, right, the smallest possible integer you can think of in this case would be 1. How ironic, right? Yeah, in positive numbers, the smallest possible integer you can think of would be 1. And how much a number is bigger actually depends on how closer it is to positive infinity in this case, right? So the closer the number the closer the number is to positive infinity, that's how big the number is. Okay, so in this case, 8 is closer to positive infinity than 6, right? So let's say we're counting 1, 2, 3, 4, 5, 6, 7, 8. 8 is closer to positive infinity than 6, right? So 8 goes further than 6, right? So based on that, 8 should be greater than 6. Okay? So a bigger number is, the bigger the number, the number is, basically that shows how close the number is to positive infinity. Okay, when we're dealing with positive numbers. That's good. So this 8 should be greater than 6, right? So let's check that out. Yeah. Okay, so let's work with more practice, and feel free to pause the video if you like to kind of test yourself. Okay. All right. So this question is still the same thing we're working on, but just different numbers in this case. All right. So based on the example that we used in the previous question, we're working with 9 and 6 in this first question, right? Based on what we did in the previous question, we know that the closer a positive number is to positive infinity, the bigger the number, right? And in this case, 9 is closer to positive infinity than 6, right? So if you're counting numbers, let's say we get up to 10 here, right? So 9 is closer to the right side than 6 is, right? So we know 9 should be bigger than 6 based on that. Okay, so based on that observation, 9 should be bigger than 6 because it's closer to the right side, which is to positive infinity, right? Okay, and so based on that, we know 9 is greater than 6. Okay, so the next one is 0 and minus 6. Okay, one thing I want to point out again is that 0 is bigger than any negative number. Okay, so when you're dealing with negatives and 0, 0 is automatically bigger than any negative number you can think of. Okay, so 0 is bigger than negative 1. Okay, because we know negative 1 is the biggest negative integer you can work with. Okay, so 0 is bigger than negative 1, 0 is bigger than negative 5, negative whatever. So whenever you're dealing with 0 and any negative numbers, 0 is always bigger than the negative number. And that's because those numbers deal with 0. Okay, for the number to be big, they have to be the closest to 0, right? And since 0 is basically the main point, it should be bigger than 0 should be bigger than all the other negative numbers, right? Okay, so based on that, 0 is greater than any negative number, even negative 6. Okay, so now we're dealing with two negative numbers, right? That takes us back to this number line. Okay, so we're gonna ask ourselves which one of them is closest to 0. Is negative 3 or is negative 2? Okay, so we know when we're counting our bomb, a countdown to our bomb, we know it goes from -5, goes to 5, 4, 3, 2, 1, push, right? So 3 comes before 2, right? And 2 is closest to 0 than 3, right? 2 is closer to 0 than 3, right? So based on that, we know in this case -2 should be closer to 0 than -3, right? So -3 isn't greater than -2. -2 is greater than -3, right? But we know -3 is less than -2. Okay, so if -2 is bigger than -3, -3 should be less than -2. Okay, so based on that, that will be less than here. And yeah, let me check that out. Okay, all right, so I want to do a quick overview on what I just went through. Okay, so we're going to be using three symbols. Okay, these symbols are the greater than, the less than, and the equals to symbols. Okay, so the greater than basically means is a particular number bigger than another number. The less than means is another number is it less than the latter number, and equals to is a number equals to whatever. Okay, so when we're working, number lines are really important in these kind of questions. Okay, we know that when we're dealing with two negative numbers, the number that is closest to 0 is the bigger number. Okay, and always remember negative is kind of like a ticking time bomb. It goes upward, downward, right? So when we're dealing with negative number lines, it goes upwards, downwards. Okay, it doesn't start from 1, 2, 3 or whatever. Okay, but when we're dealing with positive number, the number closest to the positive infinity, or the number closest to the right side, is the bigger number. Okay, but when we're dealing with zero and negative, we know zero is bigger than every negative number. Okay, and so based on that, we can yeah, we can kind of walk through this kind of questions. Okay, so thank you very much for watching the video, and I really hope it helped you out. Have a beautiful day ahead. Bye.